This is the audio notes to explain the calculations needed to do day 2 of the lab quiz. Once again, you're going to be testing the absorbance of different solutions. You had the KSCN and the burette just like before, so you have volume measurements there. Then you're going to get down to calculation number 4. That molar absorptivity value that you calculated last class is what you're going to need to do to solve for the concentration at equilibrium for all of these different solutions. So again, I will show you one example. So for example, my test tube B had an absorbance of 0.145 divided by my lowercase a, my molar absorptivity, which was 3,689, times the path length of 1.1. So this gets me 3.8 times 10 to the negative fifth molar. Again, what I was doing was taking that equation of A equals ABC, but this time I was solving for C. So that is the first step that you have to do in this math. Looking at the bottom of the page, you should have used the exact same amount of iron ion in all trials. That's why it says you only have to do one calculation. So if we're finding the initial concentration of the Fe plus 3, this is another example of dilution math like in day 1, where I take the molarity of the Fe plus 3 times the volume, which in this case I used 5 milliliters, that would give me my number of moles, but it was put in a 10 milliliter sample, which means 1.0 times 10 to the negative third molar is my concentration. And that was the concentration of iron in each trial. Since you used the burette, you used a different amount of the potassium thiocyanate in each trial, so you do have to do calculation number 6 for each test tube. So for example, letter B, once again, 0.0020 molar is what I started with. And when I did my first trial, I had a little under 1 milliliter, like 0.00096 liters. That gets me my moles, 1.9 times 10 to the negative sixth, divided by the 10 milliliter sample that it was in. I had a 1.9 times 10 to the negative fourth molarity for that trial number 1. Please pay attention to the fact that I have bolded initial concentration of SCN. Just like if you look back at the previous page, I bolded for question number 5, initial concentration of Fe plus 3, and I bolded for question number 4, at equilibrium of FeSCN 2 plus. So that is going to lead us to question 7. Question 7 is setting up an ice table for all of our reactions. We were reacting iron ion with the SCN ion to make the FeSCN 2 plus. We did not start with any of the iron thiocyanate, so I assigned that as 0 initially. However, if I look back, I did start with 1.0 times 10 to the negative third of the iron ion. And that is what you calculated in question number 5. That is the same for all of the trials. What differs in the trials is the amount of SCN that you used from one trial to another. In my trial number, letter B, I used 1.9 times times 10 to the negative fourth. The only other number that we know is we know the value of the FeSCN2 plus at equilibrium. We calculated that in step number 4. So for example, in my test tube B, at equilibrium, I had 3.8 times 10 to the negative fifth as my concentration. If I started off with 0 of the FeSCN, and I ended up with 3.8 times 10 to the negative fifth, that value must be what X is in this particular problem. Which means both reactants, since it's all a 1-to-1 ratio, are losing that amount. So then I can solve for, at equilibrium, my reactants as well. You have to do this for test tube C, test tube D, test tube E, and test tube F. Now once again, the value right here, the iron plus 3 initial, was solved for using calculation number 5. The value right here, the SCN initial, was solved for using calculation number 6. And the value down here, the at equilibrium concentration of the iron thiocyanate, was solved for using calculation number 4. Doing this will allow you to get all of the data points that you need at equilibrium in order to flip the page and do calculation number 8. Number 8 is solving for the equilibrium constant, which you can do products over reactants to solve for that. And then number 9, find the average. That should conclude how to do the calculations for day 2 of the lab quiz.